Okay, here is question number 2. It says cos x is equal to cos x tan x. Now when you're given a question like this, remember what we did in the previous one. You have to make a trigonometric ratio the subject of the formula. Here I know you might be tempted to divide by cos x on both sides, then you're left with only tan, but do not do that. So when you have, I cannot do that because this value has an x in it, this cos x, so I should get some solutions from x. So what you should rather do is collect everything on one side. So I can either take this that side or this to that side. It doesn't really matter. In the end, your solutions will be the same. So as an exercise, whatever side I take the terms to, you do the opposite and then check, are the answers the same? Okay, so what I'm going to do is I am going to take my cos x to this side. So I have 0 is equal to cos x tan x minus cos x. So I took this cos x to the other side, that's why it's negative over there. And now that I have it on that side, I will just rewrite this equation, but I will write this part first, and then it's equal to 0, because if x is equal to 0, it means 0 is equal to x, isn't it? So I have cos x tan x minus cos x is equal to 0. So I've just written this part here first, and it's still equal to 0. You can see all the signs are the same. It's positive, it's positive, it's negative, it's negative. Then from here what I do is I factorize cos x, because I can see this term here has cos x, that term there has cos x, so I can factorize it. So when I factorize cos x out, I have tan x minus 1 is equal to 0. Then you need to remember, when I have two terms multiplying and the answer is 0, it means the first one is equal to 0, or the second one, tan x minus 1 is equal to 0. So these two terms are multiplying. Cos x times tan x minus 1, I'm multiplying them, and the answer is 0. It means the first one is 0 or the second one is 0. And that is only true when the product is 0. If this number was not 0, I cannot say the first one is equal to 1 and the second one is equal to 1. I cannot do that. But with 0, it's the only exception, I can do that. Okay, so I have two equations over here. Let's look at this one. This one is similar to the one we did with sine x. We say take everything except your trigonometric ratio to the other side. So I can rewrite this one as tan x is equal to positive 1, because I have minus 1 here. When it goes to the other side, it becomes positive. Now I have two equations that I need to work out, and I will start with the first one. I'll call this one number 1 and this one is number 2. Okay, so what I do here is I have cos x is equal to 0. Then what I do is I find my reference angle, but with 0 is unique, but we can still do it with our reference angle. So here I say x is equal to, or theta rather, I say theta is equals to cos inverse of 0. Okay, cos inverse of 0, if you work this out on your calculator, if it's in degrees, you'll have 90. Cos of 90 is equal to 0, but in radians, this is equals to pi over 2. So we can check on the calculator over here, cos, can you see that? Cos of 90, you can see this is equal to 0. And there is another angle that gives us cos is equal to 0. Okay, we'll just move that up here. Okay, so there are two angles, cos of whose cos is 0. There is pi over 2, and then there is also 270. Cos of 270, we can check. Delete this. So I have cos of 270. You can see it is also equal to 0. 90, 270, 180, 360, those are special angles. Okay, so it's always good to know what is their sine, cos, and tan. So here, my solutions, I'll have pi over 2 because cos of 90 is pi over 2, or I will have 270, which is 3 pi over 2. Now I didn't take it into the quadrants because the quadrants only say whether it's positive or negative, and if it's 0, that means it lies on the line, just like this. If it is in this quadrant here, it is positive. If it's in this quadrant, it's either positive or negative, positive or negative, positive or negative. But when it's 0, that means it either lies on this line here, or that one, and that one. Okay, so if you have tan of something is equal to 0, check these values. You check 0, you check 90 or pi over 2, you check 180 or pi, or you check 270 or 3 pi over 2. One of them should give you a 0. If it is not one of these, then that means it lies exactly inside the quadrants. Now here, because I have 0 and 0 is not positive or negative, it means my angle should be one of these. And I know that cos of pi over 2 is 0, so that's my first solution. And I know that cos of 3 pi over 2 is equal to 0. That is my second solution. Okay, so I hope you're still following. And that was the first part of the equation. Then I still have to solve this one. I have tan x is equal to 1. Now this one, because 1 is a positive number, I have to follow the steps that I did in the previous one. So step number 1 was to rewrite it as tan x is equal to something. So I made tan x the subject of the formula. Step 2, just divide this. Step 2 was the quadrants. Okay, so here I have 1. 1 is a positive number. So I need to ask myself, in what quadrant is tan positive? So I go to my quadrants again. In this first quadrant, all of them are positive. In the second quadrant, only sine is positive. In the third quadrant, which is what I'm looking for, tan is positive. And in the fourth one, just for interest, we know that cos is positive. So can you tell me which quadrants is tan positive in? Tan is positive in the first quadrant and in the third quadrant. And why did I pick positive? Is because of this. I look at this number over here, 1. 1 is a positive number. So positive here and positive over there. Then the second or the next thing that I did from there after finding the quadrants was to determine my reference angle. So here I have my reference angle. Okay, now the reference angle, I will call it theta. And remember, theta should be in radians because that is what we are working with. So theta is just tan inverse of 1. Okay, this you do on your calculator to work it out, but this again is a special angle that you should know. And if you do it on your calculator and your calculator is in degrees, let's see what we get. We have tan inverse of 1. I get 45. And 45 is a special angle, so you should know that tan of 45 gives me 1. But here we're working with radians, so I need to rewrite this 45 in radians. And when I do that, I have theta is equals to pi over 4. Okay, now if you remember what I said in the previous one, your reference angle might be a solution, and here it definitely will be because one of the solutions must be in the first quadrant. So I know this pi over 4 is a solution. Now I need to find out what is my angle in the third quadrant. So I'll write over here solutions. So the two solutions, the first one comes from the first quadrant, and in the first quadrant it is just theta itself, which is pi over 4 radians. And then the second solution, we worked it out over there. We said this is from the third quadrant. And in the third quadrant, we define the angle as pi plus theta. That is the definition, or how we rewrite an angle in the third quadrant in terms of a reference angle. So I know what pi is, I know what my theta is, I worked it out, there it is, it's pi over 4. So I have pi plus pi over 4. So this is just fractions that you work out. You have pi over 1 plus pi over 4. You change the denominators so that they are the same, and I think you should get 5 pi over 4 radians. Okay, so we're done with both sides of, or both parts of the equation. So the last thing I need to do is just write down my solution, or list them all. So I will say here, solution x is equal to, now remember from cos x I got two solutions. I got pi over 2, so I should write that down. X is equal to pi over 2, and I also got 3 pi over 2 from cos x, so I'll write that down as 3 pi over 2. And then from tan I got two solutions. I got pi over 4 and 5 pi over 4, so I should write those down. So it is pi over 4 and 5 pi over 4, and then those are my solutions, and just like that I'm done.